All right, so what we're going to talk about is solving these equations that we've been solving graphically, but we're going to solve them algebraically instead, okay? And you should have done this. This should be a recap from Algebra 2 as well. So yesterday we talked about if we had this equation, let's say I had x squared plus 3x plus 2 equals 0. And we said we could take it and we could graph it. And let's see, let me think about where these solutions would be. And it might look something like this, right? This is not drawn to scale by any means, but if we were to graph this, we would find that it crosses at -2 and -3, okay? And those would be the solutions of the equations. Those are the values that make the equation true. Now, rewind back to Algebra 2, and you learned a couple different methods of doing it as well. Do you remember what one of the methods was you learned to solve a quadratic? What'd you say? All right, that's Pythagorean theorem. How do you solve a quadratic that's equal to 0? There are many, many, many methods, but Algebra 2 focused on a lot of them. Okay. Maybe if I write it, you'll remember. Quadratic formula will always work. Factor and solve. Okay. If it ever equals 0, we really want to try to factor it to try to get the pieces by itself. And the reason we do this is if we have it factored, if we have two things that we multiply together to give us 0, what do we know about one or both of those things? It's got to equal 0. That's the only way to get 0, right? So the goal in factoring is to get it down into pieces that are multiplied together equaling 0. So we can set each one to 0 and solve. I'm going to show you factoring, assuming you haven't seen it before. I know those that have me have done it this way. This is the way I teach it. But if you haven't, or if you remember how to factor and your teacher taught you a different way, you most certainly may do that, okay? But let's take the same quadratic, x squared plus 3x plus 2, and let's factor this quadratic. Do y'all remember, or do I need to run you a sheet? I have a little reference sheet on how to factor. You want me to run it for you real quick? You will see the steps in completing a factor of any quadratic there. So the first step is to factor out a GCF. And so a GCF is whenever we can divide everything evenly by some value. So if you look at these, does this have a GCF? Can you divide all three of those terms by anything with no remainder? No. So there's no GCF. So you can skip step 1 there. Second thing is to list your A, your B, and your C. And in this case, A is what? 1. What is B? 3. And C? 2. Multiply A times C. No, A times C. 2. List all the factors of A times C. So what all can you multiply together to get 2? 1 and 2. That's it. There is nothing else, right? Of your list of factors, and in this case it's only 1, so I would look at these, and I want you to see how I'm really just literally reading these step by step off the sheet. Which factors add or subtract to B? Do you see how if I put a plus in the middle here, it would equal 3, which is what the B is in the middle? Okay, so that's how you know that 2 and 1 are the values that you use. Okay, so now here's what I'm going to do. I'm going to rewrite the equation. I'm going to keep A the same, and I'm going to keep C the same, but in the middle, I'm going to use these two numbers to rewrite the 3 in the middle. Instead of 3, I'm going to write it as 2 plus 1. Does that make sense? All right. Now, next thing I want to do is I want to look at it as 2 pieces. Okay? So I always call this a slash problem. I always say slash it in half. Look at the first 2 terms in the equation. What is the GCF? x, right? I can take an x away from both of them. If you take an x out of the first two only, what is left? An x plus 2. Keep the middle sign, and now look at the last two. What's the GCF there? 1, right? If it doesn't look like it has one, you can always take one out. What's left? Now if you look, what do you notice they have in common or is the same? X plus 2. So you're going to take that away, write it one time, and then write what's left. What's left over? All right, so now it's factored, okay? The whole point was that I get two sets of parentheses multiplied together and equaling to 0. Okay, so now to find out what x equals, I take each parenthesis and I set it equal to 0 because I know if they multiply together to give me 0, then either x plus 2 is 0 or x plus 1 is 0. So I solve each one. If x plus 2 is 0, what is x? And if x plus 1 is 0, there are your two solutions. That's an algebraic solve. Okay? If I graphed it, you would see that it crosses at -1 and -2, and I'll just, nope, I won't show you right now. I'll just show you that it really does cross right there because essentially we're doing the same thing. We're finding the same thing. We're doing it a different way is what we're doing. So if I graphed x squared plus 3x plus 2, it's crossing over there at -1 and -2. Okay, let's do another factor, see what happens. Let's do solve by factoring. You always want to make sure these equal 0 before you start. 2x squared minus 3x minus 2 equals 0. What should I do? Write out your ABCs. That's right. What is A? B? Close. -3. Watch those signs. What about C? Now what? This one's a little bit more difficult because it's a negative. What multiplies to -4 but adds to -3? Yep. -4 and 1. Is it all coming back to you now? Okay. So now I do 2x squared. Instead of -3x, I do -4x and 1x. What can you take out of the first two terms? What's left? Keep the middle sign. What can you take out of the last two? I don't know how those desks have gotten turned where you have to completely turn around, Katie. Does it hurt your neck? What do they share or have in common there? So I got x minus 2, and what's left? Can you solve it from there? Sure you can. I do x minus 2 equals 0. I do 2x plus 1 equals 0. What does x equal here? What does x equal here? Yep, -1/2. You'd subtract 1 and then divide by 2. Am I going too fast through this factoring? It's coming back to you a little bit. All right, we're going to talk about another kind of solve too. About several kinds of solves, actually. So let's say you're looking at this quadratic equation. I thought we were going to, yeah. And you see something like, I'm going to leave room for a title here. Bless you. 2x minus 1 squared equals 9. How might you solve something that looks like that? Bless you. Huh? Well, you could FOIL it out and then factor it back down. But here, when you only see x written one time, we're going to SAD map, which remember is just our method of solving equations. I just threw that all the way across the room. All right, so looking at this to get x by, because x is only in here one time. Notice the other one we did, it was in there how many times? Go back and look. 1, 2, right? That's why this wouldn't work with that one. But because it's only in here one time, it's an easy solve. I can SAD map my way back out of it. So I'm looking for addition or subtraction. Remember, parentheses is last. Addition, subtraction outside the parentheses, and I don't have that, right? I don't have any multiplication, division outside the parentheses, but I do have an exponent. How do I get rid of that exponent? Square root. What's the square root of 9? That's half. That's half the answer. What's the other half? Y'all look at me like I'm crazy. You're right. It's positive or negative 3. Remember, don't forget that plus or minus. That gives us the 2 answers we're looking for. Remember, we're getting 2 answers for these because that quadratic is crossing the x-axis in 2 places. So it gives us 2 answers. It gives us those 2. Now I can finish the solve, right? So what this essentially tells me is that 2x minus 1 can be 3, or 2x minus 1 can be negative 3, and now I can solve both of those. What do I do to get x by itself now? Look at the first equation. And then what? How about here? Same thing. Add 1, only this time it's going to give me negative 2. So when I divide by 2, I get what? Yep. And there are my 2 answers. Now I need to stop for just a minute because I need to make sure if you know what to do. If this does not come out as a perfect square. So we got to go back to our simplifying radicals. Do y'all remember how to do that? I always did this to let you know you need to split them up. If you have, and this will be the case anytime you see a radical. Let's say I have the square root of 50. Is that a perfect square? No. There's not 2 things that multiply together to give you 50, right? But I can simplify it. And by simplifying, I'm looking for a perfect square that I can divide it by. What is a perfect square you can divide 50 by? 25. So let me see. We're going to look for the biggest perfect square. To divide by. And in this case, it is 25. Now, it might be helpful for you if you want to list your perfect squares off to the sides. Sometimes students like to do that. But would you agree that the square root of 50 is the same thing as the square root of 25 times 2? Okay? Because radicals have this special property that says if you're multiplying under the radical, you can split it up into 2 radicals being multiplied That's kind of what I'm going to apply here, and I'm going to split them up. I'm going to say, well, this is the same thing as the square root of 25 times the square root of 2. And what is the square root of 25? 5. So I want to put the plus or minus out front and do 5 root 2. Does that make sense? Do y'all remember doing that? All right, so far we have talked, whenever we have a quadratic, we can graph it and solve it, right? Find the zeros. We can make it equal 0 and factor and solve it. We could SAD map it if it's set up that way. There's one method that always works, and that's the quadratic formula. And it is a plug and chug kind of deal for sure. So the quadratic formula, it must equal 0 before you can use it, your equation. So let's say, and I keep saying quadratics. Y'all know quadratics means it's got a power of 2, right? The highest power is 2. All right, so let's say that I had 3x squared minus 6x equals 5. And I needed to solve that for x, and I need to use the quadratic formula. So the first thing I want to do is make it equal 0. How do you do that? 5. So I'd have 3x squared minus 6x minus 5 equals 0. Okay? Now it's plug and chug. Let me give you the formula in case you don't remember. It's opposite b, and I know that's a negative in front of there, but really it just means opposite. Whatever sign b is, just change it. Plus or minus the square root of b squared minus 4ac all over 2a. What's a? What's b? What's c? I hope we can all plug in here, right? You just need to make sure you follow the order of operations as you plug in and simplify. So if I want opposite b, then I'm going to use 6 plus or minus the square root b squared minus 4 times a times c, and everybody goes over 2. As you simplify this, make sure you work inside the radical first and then work your way out, because radicals group things together just like parentheses. So I got 6 plus or minus square root of, what's negative 6 squared? 36. 4 times 3 times 5 would be, 4 times 3 is 12, times 5 would be 60. So I got minus negative 60. Watch your signs here. They will really throw you off. Same change? Here's where you got to use your properties of radicals too. All right, I got 96 over 6. And so we'll look at a couple of things here. Everybody always wants to go, well, wait, those cancel out. The only way those are going to cancel out or simplify is if you split your fraction up. If you leave it the way it is now, you would have to divide everything by 6. Okay? I want to look at 96. Is there any perfect square that you can divide it by to get 96? I don't know. Does 4 go in? I think it does. 4 goes into 96 24 times. Something bigger than 4 goes in. How about 16? Somebody with a calculator do it.
6 times 16.
6 times 16? Nice. So what I'm doing is I'm looking at 96, trying to find the biggest perfect square. So 16 and 6, which would be 4 times the square root of 6. Y'all see what we did there? So this becomes, I'm out of room here, 6 plus or minus 4 square root of 6 over 6. That's a lot of 6's. And now to further simplify, you only want to look at the numbers in front. What can you divide all those numbers by? 2. What's left when you do? 3. That's right. That's right. Don't mess with what's under the radical. It doesn't simplify like the rest of them. I'm going to leave completing the square because what I have found is even though